Okay, so real quick, I want to get you down there, but I want to just take a quick review of the growth and decay stuff we talked about last week. Okay. So but there's some stuff you got to do on that, right? Very little, very short assignments, very simple assignments, but let's do a quick review of that. Okay, so all they're saying here is if
Bless you.
Okay, if we write an exponential function, Tyler, either move up here or move out. Take a pick, quick, one or the other. Right now, choose. Move up here or move out in the hall. Take your pick. Can't be talking. Choose.
I turned around.
I don't care. I'm telling you, you can't do that now. I'm telling you, you got a choice. Move up here or move out there. Go. Choose. Choose.
What happens if I choose the
That's fine. You can choose the hallway, but it's your choice. I don't care. But you just can't be talking. I got to talk to 36 people in here about this, and I can't be waiting on anybody. Right there then. Go. That's right. I don't want to talk about it. Go. Okay, so the exponential function is in the form, we called it a times b to the x, right? We always said that the number that's out in front is the initial value. Initial value. They call it a b. It doesn't matter. It's the number that's out in front. The number that's inside is the constant multiplier. Or I think we also called it, what else do we call it? Constant multiplier. In our book, they use growth factor. Okay, same thing though. And that's the thing that's every time x increases, we're multiplying by another power of that. So all you have to do here is literally just plug this stuff in. It's that simple. I want you to just get used to writing exponential functions. So the start value is 14. That's what goes out front. So you would just fill in the blanks. 14 times 10 is the constant multiplier raised to the power of x. That's it. That's all they're wanting you to do. Okay? Okay, what about this guy? Same thing. Same exact thing. Different start value, different constant multiplier. If the start value is 1, would we even put it out front? No, because we don't multiply by a coefficient of 1. It's just invisible then, right? It's just not there.
So if you put a 1 out front, would you get it wrong?
I don't think you would, but it's possible. And you shouldn't. You really don't need it, so you shouldn't. Okay, now what about this one? This is one that we didn't talk about one exactly like this, but you guys should know how to do this. So if you want to find the start value, remember what we said about that. That's the value of the function when x is 0, right?
6.
So what is it?
6.
No.
We're going to 8.
8. Because here's where x is 0, so this must be the start value, right? Now the constant multiplier is just what we multiply by every time we move to a new term. So it's 3, isn't it? Because we're multiplying by 3 times 3 times 3, right? And so what's this look like then? It's just going to look like y equals 8 times 3 to the x. Yep.
What is the 1, 2, 3, 4, 5 then thing? Is that
Where?
nothing?
Where?
The left side.
In the x.
Oh, well, no. That's so when x is 1, we get that, right? If I put 1 in for x, I get 8 times 3. If x is 2, I get 8 times 3 squared, which is 72.
Okay.
Does that make sense?
Yeah.
Yeah. Okay. Okay, what about this? What about this? So what's the start value?
17,000.
17,000. What's the constant multiplier? 0.9, because it's every time a year passes, it's worth 0.9 times as much as it was the previous year, right? So we're always multiplying by that. That's it. It's that simple. Okay. These are also very simple. Don't make these harder than they are. All they want here is what is the constant multiplier, and that's it. So if it's appreciating by 21%, is it going up or down?
Up.
Going up. Okay. Remember what we said about if we want to use a percent in there, instead of writing the function as a times b to the x or b times m to the x or whatever you want to call it, we write it as a times 1 plus r to the x, where r is the percentage, increase or decrease, percentage change we'll call it, percent change, as a decimal, right? So what's that as a decimal? 21%. 0.21, so I get 1 plus 0.21, and so this quantity right here becomes 1.21. That's it. Makes sense? That's all they're looking for. Okay, yes, sir.
Are we taking a test on this stuff or just assignment?
Assignments. Seniors just assignments, yeah.
Wait, when you put in like the chapter 7 stuff, into the big one.
When did I?
So there's like still like the tests that aren't in the very.
Yeah, I'll do it today.
Oh, okay.
Yeah, I'll do it today. Okay, so what's this? If it's going up 25%, what's that constant multiplier going to be?
1.25.
1.25. Good. Now let's do a negative one. What if it's decreasing by 42%?
1 minus 0.42.
Yeah, that makes sense. It's going down by 42%, so that's a decimal 0.42. So it'd be 1 plus negative 0.42 is 1 minus 0.42. What's that? 0.58. Okay? Make sense? That's it. And then the other ones, we don't even need to go through these. You're just identifying what's the start value, what's the constant multiplier, and then answering some questions. Just using the function, but that's it. Not much to it.
Yep.
Okay. So yeah, hang on, one more. How much time has this been? Actually, we can go. I think we're good.